Subqueries are very cool, and there are different types of subqueries, both in the way they're created, either simple or correlated, and subqueries can be used nearly anywhere inside of the query, depending upon the type of subquery. In the from clause, a subquery can work as long as it's returning a table, and that table could be only a single column, like a list, or a single column with only a single row, like a scalar subquery. The where clause could refer to and handle either a scalar, list, or a table, depending upon how the conditions are compared to the subquery, and we'll look at that in detail. You can even use a subquery right in an expression or as a column if it's a scalar subquery. As an example of a subquery being used as an expression within a column, here's the first one. Select Paul as subquery value. Execute this, and it returns just Paul. Let's look at exactly what happened. First, SQL Server executed the subquery, select Paul, the result is Paul, and then SQL Server executed that query as if it was simply select Paul as subquery value. Almost as if SQL Server took the result, cut and pasted the result right here. That's how a simple subquery will work. The subquery is executed and the result is pasted right into the query, and then the query is executed. Now I'm just going to Control Z to get rid of this. Give us some more room. So if we want to find the answer of all the tours that depart from Asheville, North Carolina in the CHA2 database, we can solve that in three different ways: with a regular join, a where equals, or a CTE, or common table expression. And we'll look at all three of these solutions right now and step through them. First, we'll switch to the database. This is the subquery we're going to run in a few seconds. Let's just see how that looks. We know that the Basecamp ID for Asheville is 1. Give us some more room. Scroll up. So, looking at the join version, this simply takes the tour, joins with Basecamp, and then restricts it where the Basecamp is equal to Asheville in the name. Pretty straightforward, but we want to see how to do this with a subquery. For a simple subquery, SQL Server will first execute the simple subquery of select Basecamp ID from Basecamp where name is equal to Asheville, and that is still 1. The 1 is then as if it's pasted in the place of it, and the full query is executed. We find that Appalachian Trail is the only tour leaving from Asheville. To reformat the same query as a common table expression, and CTEs are new for SQL Server 2005, the simple subquery is again used. The syntax for the common table expression then is with, and here's a name for the common table expression, and a listing of the columns that will be returned from the common table expression, as, and the code for it, which is very similar to creating a view. In fact, a common table expression can be thought of as a view that only has a scope or a lifespan of a single query. Because this creates a temporary, you can think of as a view with the name of BC, we can then reference that source, that data source, down in the main portion of the query. So it's sort of strange to start out a query with the word with instead of select, but that's how common table expressions work. Execute this. Again, we see Appalachian Trail. A couple points about common table expressions. Because it's beginning with the word with, it's critical that any code in the batch beforehand is properly terminated so SQL Server knows this is a new query. It's also possible to have multiple common table expressions listed, where you say with common table expression as, then you can refer to them all down below. One of the main reasons why developers might use a common table expression is if a complex subquery is being referenced multiple times in the main query, it can be stated only once at the beginning using a common table expression instead of stating that subquery multiple times in the main query. It's also possible to build a recursive version of the common table expression, and although Microsoft has really touted this as the primary reason for using a common table expression, you'll see when we get to the lesson on user-defined functions that a user-defined function solves recursive problems as far as navigating hierarchies much more efficiently than the common table expression. So I'll hold off on recursive common table expressions until that lesson. The important point about both the common table expression and how the subquery was used is that the subquery returned only a single value, and then that single value could be compared to a column using an equals operator in the where clause.